Okay, so we're going to be doing question number 43, and this is from the Zumdahl book. So we're going to go ahead and start reading the question. So it says the decomposition of ethanol C2H5OH on an alumina surface, AI2O3, and then we have the chemical formula underneath. And then it states, was studied at 600 degrees Kelvin, concentration versus time. Data were collected for this reaction. And plot concentration versus time resulted in a straight line with a slope of negative 4 point, second here, negative 4.00 times 10 to the negative fifth moles over liters times seconds. So the first part of the question is going to say determine the rate law, the integrated rate law, and the value of the rate constant for this reaction. So there's a couple ways to go about this. One thing that I would recommend is to have a separate sheet of paper in which you have listed your first order, zero order, second order, and you have something like this, which kind of lets you know what's going on. We have our rate law, our units, you have your half-life listed, your integrated rate law. So 1 second here. All right, so here we have our zero order, first order, and second order. And then you're going to be able to have the rate law, your units, your half-life, your integrated rate law formula, and then your plot for a straight line along with like a little chart underneath. This is going to be very helpful for the kinetics portion of the course. So again, looking back at this question, how are we going to figure this out? Well, they tell us that when they produced a graph, we had a linear type of relationship. We say a straight line with a slope of negative 4.0, right? So now we have to determine the rate law. So we do know that it produced a straight line. So if we were to look at, there's a couple of things that they give us. One is our units. So I'm going to highlight this in green. You can see that our units is going to be in moles over liters times seconds. Now, we can go and use our units, but another thing is that we have a plot of just concentration versus time. So if we were to look at our three graphs here, there are two ways I can figure this out. We have concentration versus time, and we have a linear relationship. We don't have that in the first order, and we do not have that in the second order, because in the first order, we have a natural log over time, and then on the second order, we know that is 1 over concentration over time. So we can deduce by doing so by this that it will be zero order. Another thing that gives it away is our units. As I mentioned before, our units are moles over liters times seconds. We know that for our first order is 1 over seconds. Second order will be liters over moles times seconds. So we can do either this, the first method, which is looking at the chart and looking at our units and what produces a line, or we can use our units. So we know it's zero order, so we know that the answer to this question then will be zero order. So it's asking to determine the integrated rate law. So like I said, we're going to go ahead and do that. So then it'll be, our rate law will be rate equals K. This, our concentration is of C2H5OH. And we know that it's going to have a knot, okay? And we can verify by looking here. Our integrated rate law states that for our slope, our y-intercept, we have a negative slope and we have an A naught. So we're just grabbing the information from here. And then that means that our integrated rate law then will be written as follows. We will have a concentration which is C2H5OH equals negative K for constant times T, and then it'll be plus concentration. In this case, it'll be C2H5OH, not. In this case, they do give us our slope, right? If we can look at the problem here, it says plot a straight line with a slope of 4.0, negative 4.0 times 10 to the fifth. So with our K constant equals 4.0 times 10 to the negative fifth, and our units are in moles over liters times seconds. Okay, so this will be the answer for the first order. For the first question. For the second part of the question, now it asks us for the half. It asks us if the initial concentration of C2H5OH was 1.25 times 10 to the negative 2 molarity, calculate the half-life for this reaction. Now, a particular order has a different formula that you have to utilize in order to figure out what the half-life is. And if we were to refer here, we can now look for our half-life, and we know that it's a zero order. So half-life equals concentration over 2K, as written here. So all that we're going to do is we're going to be plugging in that formula to solve for the answer. So in this case, it's going to be time half, which is written that way, equals our concentration, again, C2H5OH over, over 2K. Okay, now our units were given in the problem, so we just have to refer to the units. So we know that our slope was 4.0. One second, let me double check this. So, 1 second, yeah, negative 4.0. So 2 times negative 4.0 times 10 to the negative fifth. Okay, and then our initial concentration was given in the problem up here. So 1.25 times 10 to the negative 2. All right, so if we put that into the calculator, 2 times 1 times 10 to the negative fifth, 1.25 divided by. All right, so we should get, and how many sig figs do we have? We have 3, so we should get 1.56. And this is half-life, so it's going to be in seconds. 156.25, so 156 seconds. All right, so let's go ahead and do the last portion of it. So how much time is required for all of the concentration, which is 1.25 times 10 to the negative 2 molarity of C2H5OH to decompose? So for this one, what we want to do is we want to look back at our formula. So if we look back at our formula, we go back to the zero order. We can see here that this is our integrated rate law that forms a straight line. So let's go ahead and use this formula to figure out this answer. All right. So then it will be our concentration, C2H5OH equals negative K constant times time plus concentration again, C2H5OH not. Okay, so we do know that some of these numbers we can get from the problem itself because it was given. What we do know is our concentration. So our slope is given over here in part of the problem, so that's what we're going to get our slope. And then how much is required for all of the time? So if this is all of the time for this molarity, so then that'll mean that all our time will then equal to the concentration 1.25 times 10 to the negative 2 molarity over our slope, which is 4.0 times 10 to the negative 5th. And in this case, this is going to be, 1 second, double check here, moles over liters times seconds. All right, so if I were to put that in the calculator, it'd be 1.25 times 10 to the negative 2 divided by 4.0 times 10 to the negative 5th. We should get 3.12.5 sig figs. So then our answer is 313 seconds. Okay, and that was all.